Okay, this is where we left off the other night. There we go. Now, the steps I'm just about to show you right now do not match the steps I put up here for you to take. There are two methods that they teach, and Alex seems to prefer the wrong one, in my opinion. Okay, I've had that discussion with a couple of you already. Now, this method, you remember back before. Do you remember when we were finding on the least common denominators and renaming that we looked for the missing parts? This method they're going to show you right here is the missing parts method. Okay. So what they're doing here is they're comparing both numerator fractions. I've got a denominator of 4x here. I've got a 2x, or just a plain 2 here. So the missing parts of the common denominator of that is a 2x. 2x times 2 would give me 4x for that whole line. They put this over 1, and then this is missing a 2x also. So they take 2x over 2x for the missing parts thing, and that then gives you this. We got 1 minus 2x times 3 is 6x all over 4x. Here we have 2x times 3 is 6x minus 1 all over 2x, common denominator. That being done, they cancel what they can, okay, which is almost everything. And there's what's left. Now, I want to show you the method that follows those rules that I wrote up here the other night. I'm going to go back to there. Okay, I'm going to put this over 1. Now, what I said is find the common denominator of all 4 denominators, right? Which is going to be, well, 4x, 2 will go into 4x, so it's still 4x, 1 will go into 4x, and 2x will go into 4x. So my least common denominator of all 4 is going to be 4x. So that was my first step. My second step was to take this common denominator and multiply it times every numerator. 4x, 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 4x. Okay, that was my second step. My third step was cancel anything you can within each individual fraction. Well, this 4x and that 4x cancel, leaving me a 1 for that denominator. This 2 canceled into that 4 2 times. 1 doesn't matter, so I've just got these. This 2x, the 2 goes once into the 4, or twice into the 4, and the x goes once into the x. So times there. So what does this give me? 1 minus 3 times 2, 6, or 3 times 2 is 6x. Over everything here became 1s. Here I get 12x over 1 minus 1 times 2 times 1, 2. Everything is over 1s. Now all I got to do is split. Now, this step I'm writing up here right now, you do not need to show. Okay. What I've got to do is I've got to flip this. 1 over 12 minus 2. 12x minus 2. Okay, and I'll put a parentheses around that. I don't care if you show this step at all. As far as I'm concerned, you can go from this step straight to 1 minus 6x over 12x minus 2. Okay. Now, this thing can be reduced. Let's factor a -1 out of this. And which gives me 6x minus 1 there over 2 times 6x minus 1. Those cancel and I get -1/2. Now, the thing I like about doing it this way is you get rid of all the denominators. Okay? And when you try to flip them, it's just what's on top here and what's on top there becomes your fraction. Okay? This. So, as far as I'm concerned, you can do it either way you want to do it. Now, if you want to do it that way, probably want to use some scratch paper and then just put the answer in. Well, I guess I ought to erase. Okay, this one. Okay, let's find my least common denominator. I got a 9m, 3 will go into that, 3m will go into that, and this 1 will go into that. So my least common denominator is 9m. So I'm going to take 9m times 1 over 9m minus 4 times 9m, or 3m, no, 9m. Now I'm going to take 9m times the 4 over 1 minus 9m times the 1 over 3m. Okay. Now cancel. 1. 1. That already is 1. 1. 1. Okay. So what do I end up with then? What I end up with is I canceled out all of that 9m, so I got 1 times 1 is 1. Over 1 minus 4 times 3 times m, or 12m over 1. And then I got 4 times 9m is 36m over 1, minus 3 times 1 times 1 is 3 over 1. And really, I don't have to show this step. I can show this step as 1 minus 12m over a singular common denominatorized one over 36m minus 3 over 1. And then this thing gives me 1 minus 12m over 36m minus 3. Now, I can deal with this sum. First place, I can take a 3 out of both of these. Okay, it may or may not be worthwhile, and I can take a minus 1 out of these because of the order with the variables. So if I take a negative 1 out of this, then that leaves me with 12m plus 1. If I take a 3 out of these, that gives me 12m minus 1. You know what? This is no better than that. What? Unless I missed
Wouldn't the
something.
1 minus 12m become 12m minus 1 if you're taking on that one?
Right here, yes, it would. Thank you. So I do have something that's cancelable. Those two, so my answer is negative 1/3.
Okay.
Okay. Simple errors will get you. I didn't fully undistribute. Thank you for catching that. Okay. Question? No? Okay. Well, better erase. Now, as ugly as this one was, doing it the other way is even uglier. Because then you've got 2 different sets of common denominators to deal with. Okay, now, method 2, they're just basically saying what I told you to do. Okay. Here it talks about all individual fractions, which means multiply the numerators by that common denominator. What I've been showing you is what this method 2 is. Now, I haven't shown this because I've gone ahead and put that x squared right here and that x squared right there where the arrows say to put them. Okay? Here and here. The x squared here and here. What do you end up with? The way I showed you. Now, remember that's over 1 right there. Now, what can you cancel anywhere? What's there? X there. What's here? X there. Both of these, both of those. When I say both of, I mean x times x, not x plus x. So what does that give me then? 4x squared minus 6x over 2x minus 3. I can factor a 2 out of that. I can't factor a 2 out of this, so there's no advantage in doing it. Okay? That's the rule. Unless it gives you something you can factor more, it's not worth doing. Now, they did it. Right? They actually factored an x out, so it is worth it. Because when they factored a 2x out of this, look what it left, and you can cancel. Often that'll happen, but not always. The thing is when you factor out common terms, when you get down to this level, it only matters if it'll let you cancel something. Okay, here's another one. There has been a problem similar to this one on the final, probably 15 out of the 19 years that I've taught for WSU. Okay. So what's the first thing we're going to do on this one? We're going to fractional. I don't want to write on my tape. We're going to put that over 1, and we're going to put this over 1. Okay. So I've got y over 1 minus 1 over y over 1 over 1 minus 1 over y squared. Least common denominator is y squared. So I take y squared times every numerator. Then I cancel. Nothing to cancel here. Okay. Here, I can cancel that. And I can cancel this and just get a y, minus y there. Here, nothing to cancel. Here, all of this cancels all of that. So what have I got? Y times y squared, which is y cubed, minus, because see, all 4 of these denominators went to 1. Here, I've got a 1 times the negative y left. So 1 minus y, okay? Oh, wait a minute, what am I doing here?
You just extended your,
Oh, I did it twice, so it really is there only once. Okay, over, now we'll do the denominator here, y squared times 1 minus just 1. Now, this thing will do some factoring. We can factor a y out of this, and we get y squared minus 1. We can factor this, it's a conjugate, y minus 1, excuse me. Yeah, y squared minus 1 there. Y plus 1. That thing is a conjugate also. Y times y minus 1 times y plus 1 over y minus 1 times y plus 1. Cancel, cancel, answer is y.
I like the answer as well.
Well, some years the answer is y, some years the answer is y squared, some years the answer is 2y, some years the answer is 1. I mean, they vary it, but that fundamental kind of a problem has been on virtually every final. Okay, what are our steps here? Well, first of all, you fractionalize any whole numbers. Then what do? Find the least common denominator of all 4 denominators. Multiply that times all 4 numerators. Cancel. And then it's just a matter of how far do you have to simplify. Ooh. Ooh. There's something tricky in this. Remember what happens when you have negative exponents? You flip it or put it under 1 if there's no numbers. Okay. So that means that this problem can become 1 over x minus 1 over x squared over 1 over 1 plus 2 over x, because this -1 only applies to the x, not the 2, minus 3 over x squared. Okay, now, what's the common denominator? X squared. So we're going to multiply an x squared times every numerator. Then we're going to cancel everywhere we can. X goes once there, x times there. X squared goes once, x squared goes once. Here, nothing to cancel. Here, x to the first, cancels that, gives you x to the first up here. These two completely cancel. So what does this thing now simplify to? I've got 1, 1, 1, 1, 1. So my denominators are gone. In that sense, my double denominators. Okay, so I've got x times 1 here, or just simply x, minus 1 times 1 is 1 over x squared plus 2x minus 3. Okay. Now the question is will this factor into something that's got that in it? Well, I don't know. Will it? That's a plus, right? That's a minus, so I'm going to subtract. I'm going to have a 1, 1. I'm going to have a 1, 3. And down here, I'm going to subtract. So this way gives me 3, this way gives me 1. 3 minus 1 is 2, which matches that. For the signs, that 2 is a positive, so this has to be the positive, there's the negative. So here and here, put in the x's. So this thing factors into x minus 1 times x plus 3 over x minus 1. And we can cancel the x minus 1. That goes one time. So your final answer then is 1 over x plus 3. Now, if you follow those 4 steps I've given you, find common denominator. Well, this one had the extra quirk of having to convert those negative exponents into fractional form. Okay. But after that, it's really no different from any of the others that we've done. Now, why do I prefer method 2? Because it gives you a repeatable pattern that works with all problems instead of a method where you got to individually figure out what are the missing parts on each problem. Okay, and that's why I prefer this method. Well, let's go ahead and look at their answer. So you see they got the same thing. Well, actually, the only difference is they put in this step that I didn't show. That's really the only difference in these. Well, here's another one that's just full of negatives. We'll do the negative part of this one, but we're not going to work it to completion. This is 1 over C times B minus 1 over B times C. Down here, this is 1 over B. And here, this is 1 over C. So what is my least common denominator? BC. Okay. What are we going to do? We're going to multiply BC times all 4 of these, cancel where we can, and simplify. Okay. So that's the way we're going to work that one. Okay, another one. Now we've got expressions instead of single terms. So we're stepping it up a little bit. Now we did a little bit kind of like this one with the one that had 3 parts on the bottom before. What is my common denominator? W plus 3, W minus 3. This factors into W plus 3, W minus 3. And this is over 1. So my least common denominator in this case is W plus 3, W minus 3. Okay. So that means I got to multiply that times all 4 of these. W plus 3, W minus 3. W plus 3, W minus 3. This is a lot of writing on this. W plus 3, W minus 3. W plus 3, W minus 3. Okay. And this, of course, becomes that. Now we're ready to cancel. So this one goes one time with that one. This one goes one time with that one. Nothing we can do here, cancel. This cancels that. This cancels that. So now we're ready to see what we got left. Up here, I've just got simply W minus 3. Minus 1. So W plus 3, oh, this minus, minus W minus 3. Okay, what did I do? I took this minus times the W and this minus times the 3. Okay. All over. Here I've got both of these. W plus 3, W minus 3. Plus 9. Okay. Now then, this is one fraction bar. So I can't just partially cancel here. If I had a break in my fraction bar right there, then I could cancel the W minus 3s. But this is a single fraction bar all the way across, so I can't, it's all for and one for all. So I gotta multiply and simplify this stuff. W minus W wipes out. -3, I end up with a -6 in the numerator. This gives me W squared minus 9 plus 9, which simplifies to simply W squared. Question? What? These two equal this part by itself. -9 and +9 goes away. They cancel. So all I got left is W squared. So then my answer on this one is simply -6 over W squared. Now, technically, you call this -6W to the -2 power, but the standard is to have positive exponents, so we don't do that. But conceivably, you should. Okay, can I start erasing? Well, here's their work. I think I took a couple of less steps. Okay, here's another one. It's basically the same thing we've got. What is my common denominator? W plus 1 or X plus 1, X minus 1. Multiply all four numerators by that, cancel out stuff. Pretty much like the last problem. Okay. Guess what? We don't have to do applications. Word problems of these. Okay. What about an equation like this? Now, believe it or not, I have prepped you for this one already. Let's think back to the others. What were my steps? Find a common denominator. Okay. First step, find a common denominator. Second step, multiply that common denominator times every numerator. Third step, factor wherever you can, cancel. Fourth step, multiply, simplify whatever's left. That was my steps for those previous problems, right? Guess what? Same exact steps here. Let's look at this. What is my common denominator? 12. 2 goes into 4, so we don't worry about the 2. And 3 and 4 make 12. But I'm not going to write it as 12. Okay? I'm going to write it as 3 times 4. Okay? Now, if you wanted me to, I could. So we've got up here, we've got 1x. And we're going to take it times 12. Or we're going to take it times 3 times 4. And it's over 2. Plus, I've got 3 times 4 times 1 over 3 equals 1 times 3 times 4 over 4. Cancel. Was once there, twice there.
What about the X?
Oh, yeah, I left off an X. Thank you. X. Okay, here the 3's will cancel. Here the 4's will cancel. So what have I got left? 3 times 2 is 6 times X. 6X over 1. Plus 4 times 1 over 1. Here I got 3X over 1. But when 1 is the denominator on everything, you don't need to worry about it. So we've made this into a much simpler equation. Basically, we have cleared the fractions. Now, let's, since I've got my variables over there already, let's do this. Divide by -3, and I get X equals -4 or X equals -4 thirds this one. Okay. So this is solving equations with fractions in them. Okay. So we use those same exact 4 steps that we were using before, don't we? Okay. Well, here they go. And you can see they got the same thing I did. Hopefully. Question?
No.
Okay. Well, here they're checking. Yes, it does check. Here's another one, kind of the same thing. Common denominator is going to be 20, because 5 goes into 22 goes into 20. So we take 20 times this, so you'll have 20x plus our 10x when you cancel. Here, you would take 20 times this, and the 20s cancel, so you get 21. Here, 5 goes into 24 times, so you'll have 4x, and you solve it. Okay, this one, variable in the denominator. Okay, what is my common denominator of all of that? 15x. I would not show this step, I would go straight to that step. Then I cancel the 5 and the 15, the x and the x. 3 out of 15 is 5 up here and a 1 down there. So that gives me that. Combine the x's. And there's your answer in this case. And there's the check. Sure. How far? Is that far? Uh-huh. Okay, here's just another one, a little bit more complicated. What's my common denominator? W plus 1. So multiply W plus 1, W plus 1, W plus 1. Denominators all go away after you cancel. Same steps we've been doing. And it will check also. Except there is one important thing on this problem. Let's go back to the original problem. What number can't be here? -1. Well, 0 can't be there, and a -1 would make it a 0. So if we work this thing out and we got an answer of -1, we would have to throw it out. Okay? So anytime you got variables in the denominator, you got to watch out for that. Because that -1 that we got wipes out both of those. There is no answer in this one. Well, there's another one. And this is just stating what I said already. LCD, multiply all terms, cancel, and then simplify. More of the same. Here where we found the common denominator, we're multiplying all terms. We canceled. And this time we got a quadratic. We got to factor that. When we factor that, it comes to this. It's going to give us our two answers. It's going to give us our answer of -7 and +4. Okay. There's the check. And with that, this is just more of the same. P + 3 is a factor of p² - 9. And so it's done the same way. It ends up being a quadratic, which we have to factor to get the final answers. Okay. Either of these answers illegal? Let's go back and look at the original problem. Can I have a -p there?
No.
No. The 9 will work, the -3 will not work. Again, you got to be careful about that. Here's just proving that the -3 won't work. Well, that we don't have to do these formulas right now. Actually, never. This is just more of that virtual solving that we did earlier. And we're done for the night.
Question real quick.
Yes.
Test on Thursday.
Yes, test on Thursday over everything since the second test.
Over everything except for what?